Hello, today we are starting Unit 3A, which is Mission 1A, Solving One-Step Equations. First, we're going to talk about what we call inverse operations. They are operations that undo another operation. They undo each other. So if I had $4 and I needed to get rid of it, the opposite of adding 4 would be subtracting. So the inverse of the opposite of adding is subtracting. Then the opposite of subtracting would then be adding, or addition. So these two go together. Adding and subtracting are inverses of each other. And then multiplying and dividing are also inverses of each other. So instead of multiplying by something, if I wanted to undo that, I would divide. And then if I was dividing to undo that, I would multiply. This is why when we have our order of operations, our PEMDAS, these two go together. Adding and subtracting go together, and then multiplying and dividing go together. They're really opposites or inverses of each other. So if I gave you the operation of adding 8, the inverse of that would be subtracting 8. And then if I told you that we were subtracting 3, the inverse of that would be adding 3. And then the opposite or the inverse of multiplying by 7 would be dividing by 7. And last, the opposite or the inverse of dividing by -2. So we're looking at just the word here. The opposite of dividing would be multiplying by -2. Okay? So that one's tricky. If it's a negative number, you'd really divide by that negative number or multiply by that negative number, whatever the inverse is. So let's take a look at a couple equations. We talked in class about being balanced, meaning whatever you do to one side of your equation, you have to do to the other. Just like when you lift weights. If you're only going to lift weights with one arm, you have to do that with the other arm as well, so that we are equal. So I'm going to draw my line down wherever the equal sign is. And we want to get our variable, our letter, by itself. If you want to put a V above that, so you know that's where our variable or our number is going to end up, or letter, sorry. And then all of our numbers need to end up on the other side. So we need to move this positive 10 over to the other side. So the inverse or the opposite of adding 10 would be subtracting 10. But if I'm lifting weights and I lose 10 pounds on my left side, 10 pounds less, I need to do the same on the other side in order to be balanced. So I just draw a line to simplify. 10 minus 10 gives us 0. So we're just going to rewrite our n down here. Equal to, and then we have 4 minus 10. There are more negatives, so I know my answer is going to be a negative. Different signs really subtract. Remember, same sign, add and keep. Different sign, subtract. We have -6. 10 minus 4 is 6. So you can also check your answer. We can plug this back into our original equation. If n is -6, does -6 plus 10 give us 4? Well, -6 and 10, there's more positives. There are 4 more. Yes, 4 does equal 4, so that is correct. All right, this time we have our variable on the right side, so we need all of our numbers on the left. So we do the opposite or the inverse of what we see. We have a -4, so the opposite of subtracting 4 would be adding 4. So whatever I do to one side, I need to do to the other. So those eliminate, and we have C equal to, and now just 20 plus 4 is 24. It doesn't matter if the letter is on the left and the right, as long as it's all by itself, the letter. All right, so if you want to double check it, we can plug it in. We have 20 equals C minus 4, and C is 24. So is 24 minus 4 20? Yes, it is. Our answer is correct. Next one, we have our variable on the left, so we need all of our numbers on the right. So we need to move this -15 over to the other side, so I'm going to add 15 to both sides. Remember, a negative and a positive, those eliminates, they're opposites of each other. So we just have G equal to, And now adding these up, 5 plus 5 is 10. 4 plus 1 plus 1, that gives us 6. So we have G is 60. And again, if we want to plug it in, 60 minus 15, does that equal 45? 60 minus 10 would be 50, minus 5 more is 45. You don't necessarily need to double check it, but on, for example, a test, you might want to double check to make sure you got the right answer. Let's flip over to the back side. Here we have one with a fraction. We've practiced some fractions already, so hopefully we know how to add and subtract fractions. We just want to get our variable by itself, and we want all the numbers on the other side. So we need to move this 1/4 to the other side. It's a positive 1/4 right now, so the opposite of adding would be subtracting 1/4. So 1/4 positive and 1/4 negative eliminate, and we have x. Now we have 3/4 minus 1/4. It might help to write it out next to each other, left to right. They have the same denominator, so we can subtract. 3 minus 1 is 2, so we really have 2/4. But we can simplify that by dividing by 2, which is really 1/2. Next, do the opposite of what you see, the inverse. Here's our variable, so we want the numbers on the other side. So we need to move this 12 over to the other side. The opposite of adding 12 would be subtracting 12. Remember, the plus or minus always goes with whatever comes after it. And now 5 minus 2 is 3. 2 minus 1 is 1. So we have m equals 13. And again, double check if you want. Does 25 equal 13 plus 12? Well, this gives us 25, so yep, 25 is equal to 25. And then our last one here on this slide, we want our variable r all by itself. So we need to move this negative 9 over to our number side. I'm going to add 9. Those eliminate, and we have r equal to now 14 plus 9 more. Well, 9 plus 4 is 13. So we have 23. Make sure you're showing your steps along the way, because later on we're going to get to more challenging types of questions, and you're going to want to show your work and use this strategy. So the next two questions on slide 4 are solving on your own. So I would like for you to try those on your own and then click play to see if you got them right. I have them done here already. Hopefully you tried them on your own first. Otherwise, good luck on your homework. It is Mission 1A.